TG-DTA, thermogravimetric analysis combined with differential thermal analysis, is a technique used to study the thermal behavior of materials. It provides information about the changes in samples' weight and temperature as a function of time when subjected to controlled heating or cooling. In this technique, we can see the change in the material or sample with time by a camera fixed on the instrument. Here we have sample pan and reference pan. The sample to be analyzed is placed in a small sample pan, typically made up of material that does not react with sample during the analysis, probably aluminium, platinum or ceramic, and in this case it's aluminium. Reference pan. An empty reference pan identical to the sample pan is used to serve as a baseline for the thermal measurements. It ensures that any changes observed in the experimental sample are not due to the instrumentation itself. To start the experiment, first we clear all the data which was previously measured and recorded so that the old data did not interrupt with the new test. The instrument is equipped with a heating system that controls the heating rate and maintain a constant temperature throughout the analysis. A highly sensitive balance is used to continuously monitor the weight of the sample and reference pans. Any weight change during the experiment is recorded. And then we will give a name for our file and save it in a particular folder. Then we will give the testing parameters. After put the empty fan inside, we will re-zero it. Re-zeroing in TG-DTA analysis is an essential step in the experimental process to ensure accurate and reliable measurements. Re-zeroing involves resetting the baseline of both the thermogravimetric and the differential thermal analysis signals to their initial reference points, typically at the beginning of the experiment. It helps to improve the following parameters. It eliminates instrumental drift. It removes background signals to compensate for sample pan effects, to improve measurements, and to facilitate data interpretation. After re-zeroing it, the sample pan would be removed and the sample is kept within the pan, and then again the sample pan would be placed on its place. After placing the sample pan on its place, now the weight of the sample would be displayed in the machine. Immediately after we place the sample pan, the weight could be fluctuating. This is due to the air or any movement in the room because the sample chamber has not been closed yet. Once we close the chamber, there won't be any fluctuation in the weight. To close the chamber, press close. After close the chamber, we will set all the parameters accordingly. There are a few parameter settings. Heating rate. The heating rate is the rate at which the temperature is increased during the analysis. It is typically set based on the material being studied and the information required. Common heating rate range from a few degrees Celsius per minute to several tens of degrees Celsius per minute, and in this case it's 20 degrees Celsius per minute. Temperature range. The temperature range of the analysis depends on the characteristics of the sample and the phenomena of interest. The temperature range should be selected to cover the relevant thermal events expected in the sample. In this case, it's 30 degrees Celsius to 400 degrees Celsius. Sample mass. The mass of the sample is an essential parameter to ensure accurate measurements. The sample mass should be carefully weighed and recorded before the analysis. In this case, the machine would automatically measure it and do the analysis accordingly. The atmosphere. Atmosphere in the analysis chamber can be controlled. Example, air or inert gas like nitrogen or argon, to simulate different environmental conditions or prevent sample reactions with the atmosphere. Here, the atmosphere is air. Data collection interval. The data collection interval determines how frequently data points are recorded during the analysis. Smaller intervals provide more detailed information but may result in a larger data files. And in this case, it's selected one file, one image per second. We can hold the temperature in a predefined particular temperature if we want to study the changes or reactions which occur during that particular temperature. But here in this case, we don't want, so we are not going to click hold. During the TG-DTA analysis, the instrument continuously records the weight change of the sample and the temperature difference between the sample and the reference bands. This data is used to generate TG and DTA curves and then start the test. Then by selecting this icon, we can have the real-time observation of the sample, what's happening inside the chamber. After the machine has started, from the indicator we can see the temperature going up, and the percentage showing there is the progress. Also, the weight changes can be observed from the other side, milligram. Once the test is finished, we will call the file and we can see the curves as well as the real-time images. From the curve, by selecting an interval, we can magnify the image as well. So magnifying will give you number of images which has occurred during that particular time period. Also, we can generate images in particular timelines if we want, by clicking on that particular time, and we can make an image. Also, we can place it by dragging it to a desired place. Interpreting the different peaks, troughs, images and curves in TG-DTA analysis involves understanding the information they provide about the thermal behavior and properties of the analyzed samples. In TG curve, thermogravimetric curve, the TG curve, it represents the weight change of the sample as a function of temperature or time during the heating or cooling process. The weight loss here, the negative peaks or downward slopes in the TG curve indicate weight loss events. These can be due to the processes like evaporation, desorption, decomposition or oxidation. And weight gain, in case if it is positive peak or upward slopes in TG curve, indicate weight gain events such as adsorption or chemical reactions leading to increased sample mass. And regarding DTA curve, differential thermal analysis curve, the DTA curve represents the temperature difference between the sample and the reference as a function of temperature or time during the experiment. Here, endothermic peaks, which are peaks with positive values in the DTA curve, indicate endothermic events such as phase transition, melting or vaporization, or the absorption of heat during a chemical reaction. And exothermic peaks, the peaks with negative values in the DTA curve, indicate exothermic events which involve the release of heat during chemical reactions or phase transitions. The peak temperature in both the TG and DTA curves corresponds to the temperature at which a specific thermal event occurs. For example, the peak temperature in the TG curve may indicate the temperature of a phase transition or decomposition reaction. The area under the DTA peak integral of the DTA curve is proportional to the enthalpy change associated with the thermal event. This can provide information about the energy involved in the reaction or transition. When interpreting TG-DTA data, it's essential to correlate the information from both curves. For example, weight loss in the TG curve may coincide with an endothermic peak in the DTA curve, suggesting that a phase transition or desorption event is occurring. Here's a quick video of the 20 minutes what have happened inside. So here we can see the change in the image. It's at start it was in a kind of pale color, then it turned to kind of yellow, and at the end it turns to black. So based on this polymer material, polymer experts can interpret the data what has happened during these time intervals of these color changes. Also, we can draw lines to measure the diameter of the pan or length of the sample, or in case if we need any lengths or dimensions within the sample, we can draw lines to take the measurement. In that case, the images obtained will come along with the scale on them. Once the experiment is over, we can stop the machine, which will reduce the temperature, and we can see it from the front panel. The temperature is being reduced, and on the side there's a light is lit. This light would be off only below 60 degrees Celsius. Until then we can't even open the chamber. So this is an indication of kind of safety. So when the light is off, if we check the temperature, it is below 60 degrees Celsius. Then we can open the chamber and take out the sample pan carefully and can remove the sample.